Welcome back, geometry students. It's Mrs. Fellin. We're on page 310 of our student journals for Unit 7. And so in this last unit, what we're actually talking about is, this is kind of going to be where that completing the square and all that kind of fun stuff comes back into action. I know that we started off kind of the unit with kind of reviewing some of that, and so now this is going to be where we're going to apply it. So what we're talking about here is just finding the equation of a circle. So like if you were going to actually graph this, whether on a coordinate grid or on your graphing calculator, we're going to talk about the equation of a circle. So a standard equation of a circle, and I'm just going to kind of give you this version of it. And so what this means, it's a quadratic relationship. And so what it means is that there's a square in here, right? So the highest power of our variable is squared. What the h and the k represent, okay, the h and the k, what that represents is the center of our circle. So we call it h and k just so that we don't get confused between, like the x and the y. But h and k is a coordinate point, and so that's going to be the coordinates of the center of our equation. And then the other thing I want us to understand is r is our radius, right? And so in our general equation, it goes x minus h squared, y, and then plus y minus k squared equals r squared. And so in the equation, if you're given a number, for example, that is your radius squared, not your radius. So you'd have to take the square root of it in order for us to figure out what the radius of that particular circle would be. So this is our general form, or our standard equation for a circle. Let's kind of talk a little bit about, so they kind of give you like where this is coming from. What you might have noticed during the investigation that we did in our class, the h and the k affect your graph differently. So for example, if I had an equation like x minus 2 squared plus y plus 1 squared equals 49, for example. So what this means is this is an equation that has a center. So since our generic equation, has x minus h squared and then y minus k squared equals r squared. Like that's our generic form, right? So this equation, our h and our k, our h value would be positive 2, but our k value is negative 1. Because in order for this to be y minus k, you would have had to have k to be a negative 1 in order for us to get y plus 1 as a reduced answer. So our center for this equation would have been 2, negative 1. And then since this is our radius squared, the square root of 49, which is 7, would be the radius. And so a lot of people memorize this or learn this by thinking about, oh, it's the opposite sign. So if it's x minus 2, the h value is 2. And if it's x plus 1, the k value is negative 1. Not that that's an inappropriate way for us to memorize that or to learn it, but what I really want you to understand, it's not that this is the opposite. It's more the fact that in our general equation, there's a minus sign. And so that minus sign causes your h value to look like it's the opposite, right? So if h is 2, this looks like x minus 2. But h is still a positive number. And then same thing here, y minus k. In this case, we had y plus 1. So it looked like this is the opposite, but in actuality, it's actually just our k value is negative 1, which causes our function, or causes our graph to kind of look like that. So what this ends up doing is the h value moves your graph left and right. And so if you were to plot this, you would say this is going to move 2 to the right. So that's what that h value does. Our k value causes our function to move up and down. And so in this case, this would cause us to go right 2 and down 1. And so when we draw our circle and we kind of use our radius, we're going to go ahead and kind of sketch it using our h and our k. So basically in this unit, I just kind of want to go over some examples. So let's go ahead and kind of jump to page 311. And just kind of want to go over some of the practice. You're going to be doing some of this in class, but I thought I'd go over, kind of the more basic type equations here so that you can, when we get into class, you kind of have an idea of what it is that we're talking about. So when they ask you to write the standard form of the equation, again, what they're looking for is kind of what I always refer to as our vertex form. So it's x minus h squared plus y minus k squared equals r squared. So one of the first things you might figure out is what is the radius of your circle. And then you also want to know what the center of your circle is. So in this case, my center is at the point 0, 0. My radius, careful with your scale here. So we're counting by 2. So 2, 4, 6, 8. My radius would be 8. So if I was going to write my equation, it would look like this. X minus 0 squared plus y minus 0 squared, so I plugged in h and k into my equation, equals our radius squared. So to reduce this, x minus 0 would just be x, and then y minus 0 would just be y, and then of course 8 is 64. So what I want you to look at is anytime you see an equation that looks like this, like in other words, there's no h and k kind of added onto it, or no parentheses here, what this means is that the center is at the origin. It just means that the center is at 0, 0, which means the h and the k value are in both 0. All right, let's take a look at the second one. So the second one has a different center. So if we look at the center, we have, it's going to be at the point 2, 2. And then the radius, let's measure this length. So again, look, pay attention to your scale. This time we're counting by 1. So this would be 1, 2, 3, 4. And then all we're doing is kind of plug numbers back into our equation. So it'd be x minus 2 squared plus y minus 2 squared equal 4 squared, which is 16. So again, all we're plugging our h in, our k in, and our r value in. All right, so obviously those were ones where I gave you the actual graph of the circle, but if I tell you just kind of some information, if I'm telling you the center and the radius, same deal. All you're really doing is plugging the information back into your equation into the correct spots. So if the center's at 0, 0, you'd plug 0 in for h. And so we know that that kind of cancels out, right? Because x minus h or x minus 0 is just x. And then same thing with the y's. And then if our radius is 1/3, 1/3 squared would be 1/9. And so this would be our standard form equation. And this is going to have a center at 0, 0 and a radius of 1/3. For number 4, this time we have a center a little bit differently, but again, same kind of deal. If I plug in, so I'm going to kind of do it this way, just so you can see. So I'm plugging in -3 in for x, or for h, and I'm going to plug in -5 in for k, and 8 in for r. So again, what happens here is if I have minus a minus, this becomes x plus 3. Same thing here, this becomes y plus 5 equals 64. So when the centers kind of, the h, the k, in this case, were both negative, it causes this to be changed to a positive sign inside here. All right, so this one I'm just kind of giving you the same kind of deal. I'm asking you to so I'm giving you a point, and I'm giving you a point that's on the circle. So this one's a little bit more challenging. So let's think about, maybe grading this one. I always like to take a look at the graph. And again, I'm not looking for, like, you necessarily need to graph it to scale anything, but this has a center of 0, 0. So I'm just going to kind of write that in there. And if the point is the point 4, -3. So in other words, there's a point on the circle, 4, -3. So without actually saying the words, what they're giving you is the information for you to figure out what the radius of this circle is. So remember, the distance from the center to the edge of the circle would be considered our radius, right? So in order for us to write our equation, we need to have an h, a k, and an r. Well, they gave us the h and k. We know the center's at 0, 0. So we can plug that information in. What we don't know is that radius. So the first thing I'm going to do is figure out the radius of our circle. And I'm going to do that by using the distance formula. So if you remember, the distance formula looks like this. So it's x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root of that. So if I did 4 minus 0 squared plus, and then -3 minus 0 squared, I would get 16, because 4 minus 0 is 4, 4 squared is 16, and then -3 minus 0 is -3, -3 squared is 9. I would get the square root of 25, which of course is 5. So by knowing those 2 points, one in the center, one on the outer edge, we can figure out that the distance is 5, and therefore my radius squared would be 20. All right, let's do one more. This time I have a circle with a different center. Again, it doesn't really matter. So the center's at the point 4, 5, and this one has a circle, or has a point that's at 0, 8. So again, they're giving you the same information. They're basically telling you enough information to figure out the radius. So let's go ahead and use our distance formula to figure out the radius. So I'm going to go 4 minus 0 squared plus 5 minus 8 squared. So that would be 16, because 4 squared, and then negative 3 squared is 9. Looks like we get the same kind of answer as we did last time, so I get a radius of 5. All right, so now I'm going to go ahead and plug it back in my equation. So x minus h, remember h is your x value of your center, y minus k equals your radius squared. So that would be your general equation. All right, let's kind of move on to a little bit more challenging examples. So let's go on to number 7, 8, 9, and 10 on this next page. This one asks you to find the center and the radius and then graph the circle. So in this format here, this is what we call standard form. So remember, if there's no parentheses like here, then we know that the center is at 0, 0, because the h and the k are going to be 0. And then r squared is 225. So if we take the square root of that, we would figure out that that's 15. So r is 15. So what you'd want to do is we're going to sketch a circle. So I'm going to just go ahead and draw in some axes. And then I'm going to put a center at 0, 0. I'm going to change my scale to 5s. So 5, 10, 15. I'm just going to put a dot, 5, 10, 15. So what I do is, in order for me to sketch this circle, I kind of go, north, south, east, and west. And whatever this radius is, I'm going to call that 15 because I'm going to count by 5s. Whatever that radius is what I kind of count up and down from the center. So then do the best you can to kind of draw in a circle that looks like a circle, and that would be how you would draw in that circle. Number 8 is similar. The difference here is that the center is at, I'm going to draw my axes like this. My center is not at 0, 0. So my center here is going to be at 3, negative 2. So again, it's the h value and the k value. Because of this plus sign here, y minus negative 2 gave me that y plus 2. So again, you can think of it as the opposite and the opposite. And then my radius would be 4 because the square root of 16 is 4. So if I'm plotting these points, 1, 2, 3, negative 2, I'm going to go ahead and count by 1s this time. So that's my center. Radius is 4. So count over 4 for left, right, up, and down. 1, 2, 3, 4. I'm going to put a dot. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I kind of get my north, south, east, and west points. And then I try to sketch it as best I can, having it be looking like a circle and not like an ellipse or something different. All right, 9 and 10 are a little bit more challenging. So 9 and 10, if you notice, it's not in the right format. There's no parentheses. We've got these 2x and this 2y kind of hanging out here. So what we call this where you have to complete the square. I'm going to grab a separate sheet of paper here because I think it's going to be easier for me to kind of show you how to do this when I have a little bit more room. All right, so here is our function. This is where that completing the square comes into play. The first thing I want you to do is I want you to rearrange your equation so that the x's are with the x's and the y's are with the y's. Okay, so in other words, I moved the x's next to the x's. That's all I really did. So I want you to think about kind of these in sections. So you're going to have to complete the square. So remember the steps for completing the square for both your x values and your y values. This is what makes this one a little bit challenging. So here's what we do. So remember, our first step for completing the square is you move c to the other side. So I know we went over this at one point, but let's go over it again. So C is your constant term. So if you notice in my equation, it already was done for us. Step number 2, divide by your A value. So your A value is the number in front of x squared. In this case, your A value would be not only the number in front of x squared, but also y squared, because there's two different values that are being squared here. So in our scenario here, again, we don't have an A value, or the A value is 1 more accurately, which means if we divide by 1, it's not going to change anything. So far, so good. Step number 3, we're going to take half of your B value, square it, and then add it to both sides. All right, so here's the catch here. So we have two B values. Your B value is the number in front of like x, or in this case, x, and then also the number in front of y. So we're doing kind of completing the square twice within one problem. So I'm gonna keep this in parentheses. I'm gonna add half of B squared to both sides. So half of 2 is 1, and 1 squared is, well, 1. For the y's, I'm going to do the same thing. I'm going to take half of b, which is, again, 1, and 1 squared is 1, and I'm going to add it to both sides. So I have 2, and I'm going to add this one and this one. So all I'm really doing here is I'm doing this step, but I'm doing it both for my x's and my y's. All right, next step in completing the square. You need to factor, and this is going to be that perfect square trinomial, so it's going to kind of be in that format. And then the last step is to solve. So let's do those two steps. So to factor this, we're going to set up our parentheses. I'm just going to use different color, so that this is 4 here. And what we're getting at here is to factor this, you would take the square root of x, the square root of 1, and whatever this sign is goes down here. Let's do it over here. Take the square root of y squared, which is y, square root of 1, and then whatever this sign is goes down here. So that's called completing the square. So why is that important? Is because it takes kind of a non-factored form, so it takes this form out of your equation and writes it in what we call standard form or vertex form. So let's go back to our problem here. So this was our original problem. Now I'm going to write down kind of our new and improved equation. So this is the one we got when we completed the square for both the x's and the y's. So now if I ask you for your center, you would tell me it's at -1, -1. And if I asked you for the radius, you would tell me it's at 2. So if I'm going to go ahead and sketch a graph here, so -1, -1 would be about right here, and a radius of 2, so let's count up 2. This would be your graph. All right, let's do number 10. Number 10 is done the exact same way. And so if you notice, we're going to rearrange this and try to fit it in over here with my x's my y's with my y's, and my constant term is already on that side of my equation. So let's go ahead and follow the steps for completing the square. So we move c to the other side. That was already done for us. Divide by your a value. Well, again, in this case, the number in front of y squared and x squared is both 1, so we don't have to worry about that. So next, we're going to take half of b, square it, and add it to both sides. So half of -3. So this, maybe you want to grab a calculator. So half of -3 is -1.5. And we're going to square it, and we're going to add it to both sides. So -2.25. So I'm going to add -2.25 or subtract -2.25 to both sides. Put that in parentheses, plus let's do the same thing with the y's. Take half of b, so b in this case is 1 because it's the number in front of y. Half of b is 1/2, so half of 1 is 1/2. 1/2 squared, so if you don't know what 1/2 squared is, you can put it in your calculator, but you get 1/5. And since we're going to use, I'm just going to keep it as a decimal since we had that one as a decimal. So I have to add both of those. So I'm going to add -2.25, and I'm going to add 0.25 to that side of my equation. Okay, so I did all this. So I took half of b, I squared it, added to both sides. Now we're going to factor and we're going to solve. So for my x's, it's going to be in this format. So I take the square root of this and the square root of negative 0.25. So obviously a negative is going to become a problem. We're going to go ahead and just write it as, whoops, I forgot about that one. So actually, let me go back. I messed up here. Negative 1.5 squared is actually not negative 2.25 because I did the same thing I tell you guys not to do, which is you have to put that in parentheses in your calculator. That's actually a plus. So let me change that because a negative number squared is always positive. So anyway, what did we do here? We took the square root of 2.25 and got 1.5. And then I'm going to bring down that minus sign and put it in here. So I took the square root of x squared, took the square root of 2.25, and brought down that minus sign. For my y's, I took the square root of y squared and the square root of 1/2, which was, the square root of 1/4, which was 1/2. And I brought down the plus. And then over here, this is 2.5 plus 2.25 plus 0.25. And so all of that gives me 5. Okay. Let's go ahead, and this is now our equation that we're going to go ahead and sketch. So let's go ahead and I'm going to go ahead and draw in some axes. So we're going to go, our center is at the point 1.5 comma negative 0.5 because it's 1.5 and then my k value is negative 0.5. My radius would be at the square root of 5, which for this sake I'm going to go ahead and put in my calculator so I can kind of get an estimate of how that is. So it's about 0.2. So if we're going to sketch this, I'm going to go 1.5, which is about here, and negative 0.5. So my center is about there. And I'm going to go over 2.2. So 1, 2, this is kind of a hard one to graph. 1, 2. So I just want you to estimate here. And that's approximately what your graph would look like. It's a little hard to get this, the decimals and so forth, so I'm not too worried about that. But as long as you have the right equation and the right center and radius is what we're looking for. All right, last but not least, let's talk about, it says the point negative 4, 4 lies on the circle centered at the origin with a radius of 6. Prove or disprove the statement. Let's go ahead and kind of draw this one out. So it's centered at the origin, so this would be 0, 0, and it has the point negative 4, negative 4. Oops, negative 4, 4, sorry. So it has a radius 6. So what you're basically doing here is you're trying to show is this distance here the same thing as that? So you're trying to find the radius here to prove or disprove that it does indeed have a radius of 6. So some of this you could do like common sense, like if you graphed this, you could probably go ahead and realize that this is not going to work. However, to prove it algebraically, I would need to see you using the distance formula. So we're just going to use the distance formula. So 0 minus a negative 4 is 0 plus 4, and then 0 minus 4, and those are both squared. So I get 4 squared, which is 16, and then negative 4 squared, which is 16. I get root 32. Well, is root 32, so this radius is root 32, which again is, 16 times 2, which is 4 root 2 if you wrote it as a, reduced radical. If you wrote it as a decimal, I get about 5.7. Any way you look at this radius is about 5.7. I'm asking you, does this point lie in a circle with a radius of 6? And the answer is no. And the reason why is because this radius doesn't match that radius. And so that's ultimately what we're looking at. Let's do one more. So here has a center, this one has a center of negative 1, 2, and this one has a point of negative 4, negative 1. And so they're saying, is the radius going to be 3 root 2? So notice how they're leaving it in reduced radical form, which I like. So let's go ahead and work through this one. So again, you're going to figure out the radius using the distance formula. So negative 1 minus negative 4 squared plus 2 minus negative 1 squared. So negative 1 minus negative 4 is like saying negative 1 plus 4, which is 3. So 3 squared is 9. 2 minus a negative 1 is also 3, so 3 squared is 9. So this is root 18. Let's go ahead and reduce this. Since they gave us the radius in reduced radical form here, let's go ahead and reduce this. So this would be a perfect square of 9, so this would be 3 root 2. And so the answer to this question would be yes, because this radius is 3.2, and that has that circle that we're kind of proving or disproving has a radius of 3.2. So we can conclude that that has to be, that this has to be on that circle. All right, so that's ultimately what we're kind of getting at today. I'm going to ask that you practice this, especially the problems with completing the square. So we're going to do a little bit more in class, but I would practice this on your own with some of the big idea stuff, and then come to class with questions, and let me know what you guys kind of are struggling with. All right, that's it for now. Bye, guys.